Hello and welcome to this example video where we're going to look at solving systems of equations with the substitution method. So first, let's take a look at what we're going to do. I'm going to do this in pencil here. We'll do it in red. For this, number one, we have 3x minus 2y is equal to negative 2 and x equals negative y plus 6. Now what we're going to want to do is substitution. We're going to use that method if we have something like this. X equals something else or y equals something else. Because all the hard work is already done. Now, as the name implies, we're going to substitute this value in for x. And so I'm just going to take my time. 3 times the quantity, negative y plus 6 minus 2y is equal to negative 2. And I go about solving it. So distribute negative 3y plus 18 minus 2y is equal to negative 2. And then I combine some like terms. Negative 5y plus 18 is equal to negative 2. What I'm going to do is subtract 18 from both sides, and I have negative 5y is equal to negative 20. This means y has to be positive 4. Now this is only part of my answer. To find out the rest, I'm going to take this value and I'm going to plug it in right there. And so what I'm going to end up getting is x equals negative 4 plus 6, which is 2. As a result, my final answer here is going to be the point 2, 4. I box it, I walk away, I'm good to go. Okay, now let's take a look at this second one. So first, let me clean up my mess here, tidy all that up. All right. Now what's tricky about the second one is the fact that we don't have something as y equals or x equals. And so in this case, what we're going to want to do is do that with one of the equations. Now this is a good one because we have a 1 here, a 1 here, and a 1 here. That's ideal for trying to find a variable to solve for. What I'm going to do is solve for y in the top equation. And all I have to do that is subtract x from both sides. As a result, my new equation is going to be y equals negative x plus 20. Now we're repeating what I did in the previous problem. I'm going to take this, I'm going to plug it in there. And so if I do that, I'm going to have 5x minus, again, use your parentheses, take your time here, negative x plus 20 is equal to negative 2. Distribute. So minus negative x is actually going to become plus x minus 20 is equal to negative 2. Here I'm going to get 6x minus 20 is equal to negative 2. Add 20 to both sides. And I have 6x equals 18, meaning x has to equal 3. All right, well, again, what I'm going to do is take this x value, plug it in there. So I'm going to have y equals negative 3 plus 20. And when I do that, I end up getting 17. So my final answer here is a point, 3, 17. And here we see the beauty of the substitution method. If we tried graphing, this might not be on our graph, especially if we're dealing with a paper graph, because 17 is a really big point. However, with the substitution method, it doesn't matter how big, small the numbers are, if they're fractions or decimals, it will work every single time. And so these